If you're watching this video, that means you have seen the VSync option on your games, and you might have heard that this makes your games smoother. And when VSync works, it works flawlessly. It works smoothly. It makes your game feel much more smoother. But when it doesn't work, it makes your game choppy. You feel input lag and you get a terrible gaming experience. But why? Well, before knowing why, you need to know why VSync was first introduced. Well, VSync was first introduced to combat screen tearing. Now, what is screen tearing? I'm sure you have seen while playing a game or while doing something else, you have seen a line going through your screen. That is called screen tearing. Now, why this happens? Because your monitor is dumb. Modern monitors use top-down method to display your frames. So that means each and every single frame will start from the top and it will slowly come to the bottom, and then you will see one frame, and then after that you will see another frame, and it goes by like this. And in 60 Hz monitor, it will happen 60 times in a second. If you're using a good enough GPU, then it will produce more frames than your monitor. So sometimes when your monitor is displaying one frame and it hasn't been completed the whole process, your GPU might send another frame to display, and then your monitor will show that and it will mismatch. Then you will see screen tearing. And to combat this particular problem, VSync was introduced. And VSync works by introducing buffers or holding frames at buffers. Now there are different flavors of VSync: a dual buffer VSync, a triple buffer VSync, and a true triple buffer VSync. So let's talk about dual buffer VSync, or what is most commonly used. Think like this way: there is one front buffer and there is one back buffer. The front buffer is the frame that you are seeing on your screen, and the frame in the back buffer is the frame that GPU is currently making. So when your monitor finished displaying the front buffer, then your back buffer becomes the front buffer, and there is another back buffer which is another frame making in the GPU. But it doesn't always works optimally. So sometimes your GPU cannot finish making the back buffer frame at the time your monitor finishes showing its front buffer. So then the front buffer stays there for 2 cycles until the next frame is finished on the back buffer. Then it can push it to the front buffer and then it gets normal. And when this kind of anomaly happens, you see some major frame drops and some major input lags. Now there are some games which use a triple buffer system, and triple buffer system is similar to dual buffer. Now you just have one more extra buffer. So when the first back buffer couldn't finish its job in adequate time, then the GPU doesn't hold its working process, but it works on the second back buffer, and the front buffer shows for 2 cycles, and at that time the first back buffer finishes its job, then it displayed in the front buffer and then the second buffer, and it goes in that cycle. But as you can see, we eliminated one problem, and that is GPU stalling for a long time, but it still have the same problem, a frame that is showing for 2 cycles. And to combat that, we have a improved triple buffer or the true triple buffer. Now the difference between the normal triple buffer and this triple buffer is very simple. So in normal triple buffer, it works sequentially, but in true triple buffer, it doesn't work sequentially. So while your monitor is displaying the first buffer or the front buffer, the GPU is constantly working simultaneously on multiple buffer, or let's just say 2 more buffers. And if the second buffer couldn't finish its job at that time, like at the time that your display is finished showing the front buffer, then some other buffer or some other frame which has already finished its processing or its making process, then it will go to the front buffer, and the second buffer would be discarded, or the buffer that hasn't been finished would be discarded. Now I know this sounded very complex, but it also has its problem, and that is an inconsistent path of working. So your first frame is here and your targeted frame, let's just say frame 4, is here. And what happens normally? Let's just say frame 1 is here, the second frame is here, the third frame is here, and the fourth frame is here. But using true triple buffer, you might see these kind of problem. Your first frame is here, your target frame or the frame 4 is here, but the second frame which was supposed to be here, and it is not here, it's right alongside with frame 3, and you will see some inconsistent jitter while you are playing your game. Even though you are running at a high frame rates, you might experience some micro jitters. So all in all, VSync is not a complete solution, or at least the VSync that has been developed or implemented in-game basis. But there are other flavors of synchronization or frame synchronization technology, especially from NVIDIA's G-Sync and from AMD's AMD FreeSync. Now these two works on a very different mechanism, which gonna be a topic for some other video.